Good afternoon, Professor. This is Stephen Manohar Gurram, one of your students from machine learning class. This is my solution to the assignment. So in this solution, I first imported all the important libraries for this particular assignment. So the first part of the solution is concerning about the principal component analysis. So yeah, this particular principal component analysis, we do it in order to have the principal components of a data set and only the required data. So we're only going to take the required data and then we leave the other data. So the first step I did was I just imported all the data set. I imported the data set from this particular link. This is the drive. This is in my drive, D drive. So I imported that and then I applied the basically I applied the function on it. So basically what I did is the data set has some null values. So in order to fill in those null values, I just calculate the mean of the entire column and then fill the value with these null values so that we have a complete data set. So once I have the complete data set, I applied the PCA on this complete data set. So in order to get the principal components, which is the number of components is 3, so we got 3 components here. So so after that I just applied the k-means clustering to reduce, I applied the k-means clustering to the PCA data. I did this because we can after doing this we'll get a range of we'll get a range of 1 to 10 groups. So we'll get a range of groups from 1 to 10. So we can calculate, we can select those 4 or 3 groups from these 10 groups. And then we calculate the silhouette scores for these groups based on this graph. So that's what we are doing here. We're just calculating the silhouette scores. So after applying the k-means clustering, we choose 4 groups based on our graph and apply the k-means algorithm to divide the data into these groups. So basically, and then we see how well it does by the groups. We see how well it does by calculating the silhouette scores. So scaling and PCA again. So we're going to scale the PC again. Then we try a different method where we first scale the data to make all values similar in range, and then apply PCA with two main points instead of three. So first we apply it for three main points, but now we are applying it for two main points. So we are only getting two. So here we did the two, right? And then we apply the k-means clustering again and do the entire process again, and we find the silhouette scores. So coming to the second part of the assignment, which is speech data with SVM using this particular data set. So I just imported the data set, and as with previous principal component analysis, I basically filled in the values like I scaled the data set so that I'll get only the data that is really essential for the assignment and leave the rest of the data. And then we scale the data to speed up the data so that all the values are similar in range. So we are just eliminating all the values that are not similar, that are not so useful for our analysis here. So we use PCA to reduce the number of columns into just three. Again here, we use PCA to reduce the columns to three here. Uh, and then we apply the SVM classifier. So we basically apply the SVM classifier in this particular block. So the accuracy of the SVM classifier is given here. And then after applying the SVM classifier, we use the machine learning model called SVM to classify the speed data into different categories. Um, and we basically classified the output of this particular model is printed here. So we basically classified the accuracy into three. So precision, recall, F1, and support. So precision is like is nothing but the formula for precision is nothing but um, TP by TP plus FP. So that's precision. And recall is TP by TP plus FN. So these are the truth values, and F1 score is calculated by precision into recall by precision plus recall. So these calculations are done for the entire data set, and it is displayed here. So coming to the third part of the assignment, which is apply a linear discrimination analysis LDA on the iris dataset. So I basically imported all the iris dataset that was provided, and then once I imported it, I just did the basic data scaling again. So I did the data scaling again and encoding the species here. So once I did the data scaling, yeah, I basically printed the data into a graph to like showcase it. And then we convert the species name into numbers here. Yeah, so first I imported the dataset and then we convert the species name into a graph, into a numbers and applying the LDM here to reduce the number of columns to just two main points that best separate different types of flowers. So iris is like a flower. So we have multiple iris species. So yeah, that's what it is. And then at last, I just plotted all the data here to yeah display it. And then the fourth part of this is briefly identify the difference between PCA and LEA, because in PCA we are essentially like decreasing the data to the principal components. In LDA we're essentially doing the same but linear discrimination analysis. So yeah, that's the difference is the answer for that is written on the screen. Is PCA performs better in case when the number of samples per class is less, whereas LDA works better with large data sets having multiple classes. Classes separatability is an important factor while reducing dimensions. PCA finds directions of maximum variance regardless of class labels, while LDA finds difference of maximum class separation. Yeah, this was a helpful exercise for us. Thank you for giving us this assignment. Have a great day.